Hello everyone, this question is in continuation with the previous two questions. What we have done here is that this AM block has been given a charge Q and there is an electric field in the upward direction. Okay, so those who don't know the force due to electric field, let me tell you that the force due to an electric field is F is equal to Q times E, where force direction is in the direction of electric field if Q is positive. If it is negative, it will be in the opposite direction. Okay, so that information is enough to solve this problem. Now what is asked over here is that what maximum horizontal force should be applied on the small am such that the equilibrium is not disturbed. So let's do this question over here. Let me say that the small am block is like this. So towards left there is a direct force applied towards left. Towards right there will be frictional force mu times n. Okay, basically n is the normal reaction. We have seen in the previous question that one. N is the normal reaction by capital M on small m. And downward force mg is there. And this case tension will also be there, right? Towards right, the tension. So this is the tension T. So we can write F is equal to T plus mu n. One more force that we forgot is that electric force, electrostatic force, that is upwards, Q times E. So now this is upward force. So we have N plus QE is equal to mg, right? So this is our second equation. So from here N is equal to mg minus QE, right? So if I put this equation in the first equation, what we will get is we will get F is equal to T plus mu times mg minus q times E, right? This is what we get. So now what is the tension over here? The tension is, how will you find the tension? So on this block capital M there is a tension T again here, and there is no friction between capital M and the ground, right? The frictional force on the capital M block is towards left, right? It is towards left, that is mu times n. So here we have T is equal to mu times n, right? Why T is equal to mu times n? Because the frictional force basically between the floor and the capital M is 0, and mu n is the frictional force by the small m on the capital M, right? So here T is equal to mu n. So F is equal to mu times n plus mu times mg minus QE. So now n is again mg minus QE. So this will become 2 times mu mg minus QE. That's what you get once you substitute n to be mg minus QE. This is your new force. Okay.